Hello and welcome to Planes, Trains, and Hyperloop conversation. My name is Shinran, and thank you for joining us today. I'm super excited about the amazing panel of awesome experts we have with us to discuss this incredibly novel technology, which I'm told actually has its roots much further back in history, to the 1800s, in fact, and with someone called George Medhurst of London, who conceived and patented an idea for an atmospheric railway that could convey people or cargo through pressurized or evacuated tubes. But it didn't really take off, and it was largely forgotten about until it was brought back to the public attention by none other than Elon Musk. And since then, there's been a lot of development in this field, and I'm very much looking forward to hearing the latest from our panelists. And we have live transcript enabled. It's automated, so it's not always accurate. So please be aware of that. And if you can find it by clicking show subtitles if you want to see it, and you can hide subtitles to remove it. Right, on to the main event, and it's over to Tom, our co-founder of Socio, to introduce today's event. Over to you, Tom.
Thanks, Shane. Well, over the next hour, you're going to be hearing about the development of Hyperloop technology and how an award-winning team of students at Edinburgh University have managed to drive it forward. I'm not going to give too much away, but it's safe to say there's some cutting-edge stuff here that could have some huge implications on how we might all want to travel one day. I'm really happy to introduce four members of Edinburgh University's Hype Society. We have Hype President Stella Antonianaki, Secretary Gregory Dyer, Aral Chalhan, who's the technical manager, and Nordin Mizmar, who I think is the only non-engineer here, who's a law student handling Hype's outreach operations. Overall, we hope today will help you learn not only about the science and the engineering that underpins Hyperloop technology, but also what's been motivating the students to achieve what they have. We want this to be interactive, so please don't be shy about asking any questions. You can do that by sending it through this chat function here on Zoom, or if you're viewing live on Facebook, then type your question in the comment box and we'll pass it on to the speaker as soon as we can. I'm going to very quickly introduce Socio, the organisation that's helped put this event together alongside the Rutherford Appleton Laboratory. Socio creates events and platforms that give you access to scientists and other experts, and hopefully inspire people to pursue careers in science, technology, engineering, and mathematics. We're recording today's session and making it live, not making it live, we're making it available on YouTube, so if you want to watch it again, our account name is Socio.org, that's SCIOORG. It'd be great if you could subscribe while you're there. It really helps us a lot, and it means that we can easily keep you updated with future events. And if you enjoyed the panel today, please do share the recording with your friends. Well, that's all from me for now. I am going to hand over to the team. Over to you.
So thank you for the introduction. Like you said, my name is Gregory, and I'm going to start off today's presentation about Hyperloop and about Hyped and about what we do. So to go through what we're going to be discussing today, we're first going to start with what is Hyperloop? Well, to answer this big question of what exactly is this novel technology. And then from there, we're going to discuss how it actually works from the technical aspect. And then from there, we're going to talk about how we can actually introduce a Hyperloop network in the UK. And that is when my colleagues are going to take over to discuss findings which we've done within the team for a proposed Hyperloop network in the UK. And then further discussing the socioeconomic aspects of said Hyperloop network and how it, and these aspects and when we integrate Hyperloop into everyday public transportation. And then we'll finally finish off with what is Hype, what have we done, how we were founded, and what are we going to do in the coming years. And of course, we'll have plenty of time for Q&A at the end. So as was previously mentioned in the introduction, Hyperloop as a concept is, of course, the idea of a magnetic levitating train within a near vacuum environment, or in a tube, as I will refer to it many times through my part of the presentation today. And as was said, this was not actually invented by Elon Musk, but rather popularized by Elon Musk in 2013 with his Hyperloop Alpha white paper, but actually dated back in 1799 with George Medhurst. But with the popularization of Hyperloop in 2013 by Elon Musk, here comes a lot of startups and small companies actually wanting to make Hyperloop a reality and make this actually a everyday form of public transportation, which then goes to recent developments, starting with, of course, everyone may have heard of Virgin Hyperloop One, the one company that's had the first successful passenger test journey on the 9th of November 2020. So that was a very exciting day for all of us in the Hyperloop community. So not only do they have a working prototype that can carry passengers, but they also focus on many other aspects, including passenger experience, as you can see on the slide in the middle picture. And other companies also include Hyperloop Transportation Technologies, Heart Hyperloop, Celeros, and Novomo, all of these being based in Europe mostly. And they focus on many aspects from the infrastructure side of Hyperloop, such as the actual transportation pods, for example, or infrastructure side, sorry, referring to the tubes of and the track of the Hyperloop network, or the transportation pod sides, or the passenger experience as well. The one issue which we're going to have in the near future, 20, 30 years from now, when Hyperloop becomes a part of our daily lives, is how can we actually integrate all these different designs together, since we have 5, 6, 7, even more companies coming up with their own unique designs. How are you going to make one Hyperloop network that can go from, for example, North America all the way to Europe? Such as different types of track, different types of tubes, different types of transportation pods. All of these vary across all these companies, but more on that later when I pass it on to my other colleagues. But now let's answer the big question. So how does this actually work? So the first 3 things we love to point on is, first of all, we need to create and maintain a near vacuum environment in a tube chamber. Secondly, we need to levitate the pod because, levitation is cool. And then finally, we need to propel the pod forward in some economically feasible and fast fashion, because Hyperloop is fast. That's the whole point of it. So here's a short animation which will help me explain how this works. As you can see here on the slide, you'll see a Hyperloop pod and then passengers entering. And then, of course, you see the tube's doors closing, which will create that near vacuum environment which we were discussing. And then, of course, as the pod leaves the station, the pod will levitate. So there's no contact with the actual track. And then, as we discussed, Hyperloop is supposed to be fast. And in this near vacuum environment, there's very little air, which means that there's going to be very little drag when the pod is traveling in the tube, thus conserving energy and then allowing the pod to achieve much faster speeds, which of course make Hyperloop very unique compared to other forms of transport such as trains or the current maglev trains even. So that's a quick animation about what Hyperloop is, and then to touch on a few extra points. So I talked about levitation, making the pod not touch the track so there's no friction, and then it saves energy. So for levitation, there's 2 main types of levitation, such as active levitation, which is electromagnetic suspension, and then also passive levitation, which is also known as electrodynamic suspension. So focusing on active levitation uses the force of magnets attracting the metal track within the tube. And then this is a more controlled version of levitation, such as flying cars, if you may have seen that in movies, for example, or any alike. So you can imagine a Hyperloop pod levitating from the track in the tube as it leaves the station, as you saw, which would, of course, contribute to what makes Hyperloop unique compared to others. On with that, we're going to talk about the propulsion system of this Hyperloop pod. So the propulsion system, it works on the same fundamentals as an electric motor. As you can see on the left, we have a few animations and a labeled diagram. So an electric motor consists of a rotor, which is a magnet oriented in a circle that rotates, and then a stator, a stationary electromagnet in a circular orientation, which surrounds the rotor, as you can see. And then, of course, as you pass a current through the stator, this produces a magnetic field and lets the rotor spin. Yes, we know that. So now imagine if we get this stator and make it linear, as you can see on the right, and then this will then produce an electromagnetic force in a straight line. So this is known as a linear motor. I'll refer to it as that. There are different types. But with this, of course, if we have a straight motor, you have to have a really straight track. So we're not going to be taking this Hyperloop pod at any tight corners or anything. Since it's going really fast, I don't really think you're going to want to take those tight corners, which we'll soon discuss later. So with this linear motor, we're also going to focus on the infrastructure of the actual Hyperloop network, specifically the infrastructure side propulsion. So this means that the stator is in a linear arrangement on the track, and then the rotor is on the pod. So of course, this is speaking with regards to the linear motor, of course. So since the stator is on the track, all the power that propels the pod forward, all the energy that's required to power this propulsion system is coming directly from the power grid through the power lines down into the Hyperloop tube, since the stator is part of the track. And then with this, on the pod, you don't need to have to store all these large batteries that take up a lot of weight, since all the power is, since the propulsion system is essentially on the infrastructure itself. So although this is a very efficient system, there are some downsides, such as it's very expensive, as you can imagine, since every single section of the track has to have this exact design. And of course, if a certain section of track breaks down, no pods can go through, which is a little different compared to if a bus breaks down, you can just have another bus come around and pick up the passengers. Nonetheless, you're going to have a lot of contingencies and backups with all these systems to ensure a safe and pleasant and on-time journey, I'll say. So one quick thing I'll touch on before I pass on to my other colleagues is that we're making this pod go really fast. It's going to levitate, it's going to go really fast. How do we stop it? Well, if you think about it, you can actually just get this linear motor and just flip the direction and actually have it produce an electromagnetic force in the opposite direction, and that'll stop the pod. The other option, of course, is to use friction brakes, just like a normal car, of course, which I think for anyone wanting to enter a Hyperloop pod, they'll want some sort of friction brake to stop the pod rather than relying on electromagnetism and all of this, which I think is more safer and more appealing to the public, I'll say, in my own personal opinion. So with that, I'll go ahead and pass on to Stella, who will discuss introducing Hyperloop into the UK. Thank you.
Thank you, Gregory. Hello, everyone. I'm Stella, and I've been the research director at HYPE this year and will be the president for the next academic year. And in fact, introducing Hyperloop into the UK is what the research team has been working on this past year. So there are a few things to consider when designing a route, a Hyperloop route for the UK. First of all, it's fair to say that the Hyperloop Alpha white paper was published in many ways as a challenge to the high-speed rail project that was announced to serve the area between San Francisco and Los Angeles. And it was Hyperloop was posed as a better option to replace this high-speed rail project. However, in Britain, with the high-speed rail project being HS2, it would be unrealistic right now to imagine that Hyperloop would be able to replace HS2 at this stage of development. So the two systems would have to coexist without each or the other becoming redundant, and that means they should serve different purposes, at least to some extent. Another thing to consider is that the terrain is not ideal for Hyperloop. Hyperloop routes are best suited to corridors that are, for the most part, straight and require minimal turning. And so it might have to be that the working speed of the pods will have to be adjusted to avoid subjecting the passengers to painful G-forces. And another thing is that there might be some obstacles that can be more easily avoided by making the system underground rather than overground, which was the original plan, to have Hyperloop on pylons. And although this solves quite a few issues, it also increases the cost of construction quite a bit. And that is why we think that it would be best suited for small regions of the route where it is absolutely necessary, rather than making the entire system underground. This would also minimize basically the disturbance in the surrounding area during operations. There would obviously be some disturbance during manufacturing, but that is unavoidable either way, so we can't really do much about that. So with all of these things in mind, our research team designed a new route for Hyperloop in the UK, which you can see on the left of the slide. Instead of going through city centres like the HS2 route would do, we decided to take our route through airports. And this way, the purpose of it would be to aid in making the UK into a travel hub rather than connecting city centres. And so the two systems, as we mentioned, would serve different purposes. You can see our route with the HS2 route on the picture on the right of the slide. So our route is going through 8 stations near airports, specifically 2 airports in London, Gatwick and Heathrow, and then Birmingham, Manchester, Leeds, Newcastle, Edinburgh, and finally Glasgow. The hope with this route in this plan is to basically make the UK into a mega airport where people travel between 2 routes in a similar manner that, not between 2 routes, sorry, between 2 airports in a similar manner that we move between airports. And that would basically make it a lot easier to travel through the UK. It would also be important to mention that to avoid having to decelerate and accelerate many times within a trip, the pods would go from the beginning station to the destination of the trip without stopping in between. And although this might pose a bit of a timetabling challenge, we think that it would help save a lot of time because, again, accelerating and decelerating is a time-consuming process because of the fact that we don't want to subject the passengers to painful and harmful G-forces. So there's a limit to how fast we can accelerate and decelerate. At certain points along the route, the system would go underground, as mentioned before, and that would be in areas that are very densely populated, where Hyperloop would pose basically a disturbance for the surrounding area, and other obstacles that cannot be avoided otherwise. Again, that would be kept for small regions of the route and would not be everywhere. With all of that in mind and this new route, it's important to discuss what we expect the socioeconomic effect on the country would be. So obviously Hyperloop would be a new way to go from point A to point B a lot faster than before, and that's expected to change the way people travel and the way people approach travel within the country. On a national level, this route would help turn the UK into a global travel hub. As I said, making basically the whole country into a mega airport. Obviously, there might be some limitations to that because there would be extra security checks and things like that, and dealing with baggage passengers would perhaps have to do differently than they do when they just go from one terminal to a different one within an airport. But still, if it could be in a similar manner, then it would be perhaps easier to distribute the load of passengers to all 8 airports involved. And that, again, would help reshape the air travel market. It's also fair to say that Hyperloop could take on quite a bit, if not all, of the burden of domestic flights and basically make those perhaps not unnecessary, but more uncommon. And that would be great because domestic flights are in fact among the least environmentally friendly flights one could get. On a more regional level, we think that increased accessibility would perhaps make the UK economy less London-centric. The new route would give people the ability to work in one place and live in another one, making it easier to bring economic prosperity to regions near Hyperloop stations. And this would not just be relating to the cities, but also the regions around the cities. Obviously, perhaps Manchester doesn't need much help, but because it's already quite a big city. However, the regions nearby would also benefit from having a Hyperloop stations close. All of that being said, the effect and the magnitude of this effect on the country would depend greatly on demand and how many people choose to switch to using Hyperloop. And demand can be broken down into two categories, and those are existing and induced demand. With existing demand, we're thinking of people that are already traveling between two regions and they might switch to using Hyperloop instead of whatever they're currently using. And induced demand is about people that might start traveling between two regions because of the existence of Hyperloop that wouldn't have traveled between them before. Both of these types of demand are difficult to estimate in advance, and especially induced demand. However, we can think of a few reasons why people might choose to travel using Hyperloop. And basically, it comes down to it being a lot faster than many of the other options. I believe it's even a bit faster than flying, depending on which estimate of speed you go with, and different companies have different ones. And it is also environmentally friendlier for the more conscious of the environment people out there, which is great. It is a bit difficult to say if it would be cheaper for the passenger though, because at this point in time, cost estimates are not very accurate, and there's a huge range of cost estimates. In fact, I believe it is something between $18 million to 56 or 50 something per kilometer, which is quite a big range for something that would range many, many kilometers. And it's even more difficult to decide how much of that cost would be carried by the passenger. However, it might be one of those cases where the more time the system exists and the more people use it, the more prices become more affordable for everyone. And all of these things are reasons why people might choose to switch to Hyperloop. And especially when it comes to induced demand, there are certain situations, as mentioned, people might start working in a different city to where they live, and that would obviously not be possible if there wasn't a very fast and generally cheap mode of transport between the two places. So this is a reason why people might choose to start traveling when they wouldn't have before. So this is it for Hyperloop in the UK. I'm now going to pass on to Noor, who's going to talk about the socioeconomic and environmental aspects of Hyperloop technology in general. Thank you very much.
Hello. Hi. My name is Noor. I'm the outreach director here at Hyped, and I'm going to walk you all through the kind of socioeconomic and environmental impacts of Hyperloop technology and what we're trying to do here at Hyped. So if we look at this slide, this kind of denotes the global CO2 emissions from transportation. The main, as you can see, is road transportation and also aviation. Our work here at Hyped echoes the global call for a greener, more sustainable, more environmentally conscious future with the aim to reduce CO2 emissions and plug the gap for demand of domestic aviation and travel. So Hyperloop technology in general tries to target these three kind of subsections of the market, which is road transportation, both freight and passenger, and aviation. If we look at the next slide, you'll see that 34% of UK emissions is due to transportation, domestic transportation. And that's a huge part of the economy, given that, huge part of the CO2 emissions within the UK, factoring in other reasons for CO2 emissions, such as electricity within households, heating, manufacturing within the country. So this is a big proportional segment of the UK CO2 emissions. For the UK to aim towards net zero by 2050, this is a kind of target area that they should be prioritizing, and we are trying to prioritize and kind of contribute to the global discussion on. So renewable energy and local climates. Now, the good thing about Hyperloop system is that it would span the length of the United Kingdom. And if you can look at the map towards the right-hand side of the screen, you'll see that the UK is well positioned in the sense that it has different means of generating renewable energy throughout the entire, potential length of the Hyperloop circuit system. We've got wind ports scattered throughout the United Kingdom, solar hubs that are ripe for expansion and to generate the required wattage to power such a big network of Hyperloop system. There are also a few hydroelectric generating ports that we can utilize and leverage. And then there are a few other scattered means of generating renewable resource. The main point that I'd like to take from this slide is that the UK is well positioned to leverage energy all across the supply system. And this is quite important with a system this big, because you'll need to power it with not only a lot of energy, but also powered in such a way that it's continuous and will weather different climates and different weather situations. So it's good to have a mixed portfolio as is shown on the screen. And obviously it's very secure. So another point that I'd like to touch on within my section is sustainability and renewable energy, but that the Hyperloop system is geared towards this from inception. It uses an electromagnetic propulsion system, which is obviously fully electric powered, zero carbon emissions from its operation because it's covered by renewable sources, and a vacuum tube and levitation. These maximize the efficiency of the whole system. I mean, the whole point of using Hyperloop over other transportation systems is that it's more efficient and more quicker. And with efficiency comes the double barrel sort of benefit of using less energy, generally speaking. And that means we're able to use renewable energy and not overuse the national grid, so to speak. If we look at the next slide, this is kind of like a conceptual thought that's been played around with in the Hyperloop system or kind of community, and that's to affix solar panels towards the outer cladding of the Hyperloop pod, or sorry, rather tube, and that will mean that there's instantaneous derivation of electrical energy, which is converted and obviously used to power the pod. And this is one such way that renewable energy is integrated within the mainframe or within the main grid of the whole Hyperloop system, such that it's continuous and it's accessible everywhere. I would like to now touch upon the socioeconomic impact. My colleague Stella also touched upon this. There are just a few other things that I'd like to add, with adding on top of the main benefit of there being an alternative to planes or trains or cars. The main benefit that we get from Hyperloop technology is that it will change the perception of distance. That means that distances thought to be too long or would require 2 days, or I don't know how long, an entire day of driving, such as from London to Edinburgh, an 8-hour drive, can become infinitely, well, not infinitely, but very short. That means that people are able to move around the UK more freely, more quickly, and able to engage with businesses, conventions, educational seminars more freely and more accessibly. Hyperloop technology also will be able to contribute to this whole theme of a kind of commuter city, or a city that can commute to a major hub, where there are more jobs, higher paying jobs, jobs that demand higher skilled labor, which they can, obviously train and access these markets that they couldn't previously access in their hometowns. And that only brings prosperity to the whole area, generally speaking. And also the other added benefit is that it reduces congestion. However, the main issue that Hyperloop technology has, or that has been touched upon also by my colleague Stella, is that it's quite an expensive endeavor, because everything has to be thought out from scratch. It's a bespoke project. Yes, there are some similarities with rail, and some logistical sciences can play a hand in this. But generally speaking, Hyperloop technology, in terms of the technology present, in terms of the infrastructure, the way it's going to be built and integrated, is a very unprecedented endeavor. So this will be very expensive, because there's going to be a lot of double checking, there's going to be a lot of advisors, there's going to be a lot of case studies. So the main thing to consider here is, or what will kind of gauge how accessible this is to the public, is the extent to which the government is willing to sort of bankroll or subsidize such a project or willing to invest in such a project. Investing in such a project obviously brings jobs, brings prosperity, brings injection into the economy. But also, I mean, the human capital of the UK would increase significantly because we're training people to be more specialized, better equipped, and then we can export these expertise outside the country. So if the government does subsidize or will subsidize for, I don't know, 4 years of the tickets until these companies start making a profit, will determine how accessible such a system is for the everyday user. Next, we will look at the sort of health and safety aspect of Hyperloop technology. From the beginning, Hyperloop technology has integrated health and safety within its sort of master plan. And I think that's the right way to go about that. They've taken lessons and what they've learned from different sort of modes of transportation and applied some of the main takeaways into Hyperloop technology. I mean, some of them you can see, such as oxygen supply, would be, of course, a main concern, given that it's in a near vacuum tube and no oxygen isn't good for us. Telecommunication difficulties may present an issue due to the high speed. And obviously maintaining the vacuum will be one of the major parts of constructing a Hyperloop system, because without the vacuum, then there's no point in having a Hyperloop system. It's just a levitating train. But many of these concerns are being addressed by engineers and constantly being addressed by engineers and researchers. I mean, one such example is the concept of a safe haven, as you'd have in a tunnel where there's no escape, or I don't know, on the Eurostar, where you would go and you'd kind of hide out and weather the issues at hand or the hazards at hand. And then when it's safe to do so, you'll be rescued from that position. So that's my section. I'm going to hand over to my colleague, Errol, who will walk you through what is hyped.
Hello, everyone. I'm Errol, and after talking about what is Hyperloop and a possible UK Hyperloop route and the socioeconomic impacts of it, now I'm going to talk to you about what is Hyped, what are we doing in Hyped as its members. I guess the dictionary definition of it is a student society which works on innovating the Hyperloop technology. But I think to go in deeper, a good start is introducing the teams and the people who are actually working on it. We have 4 main teams: technical, research, outreach, and public relations. The technical team produces pod prototypes, develops new technologies, tries out and innovates the Hyperloop technologies itself, and creates actual prototypes of it and tests it. And research goes into a larger scale, makes projects of infrastructures, comes up with research papers and explains it in a lot more detail. Our outreach team goes up to people, gives seminars, gives lectures, makes online courses, and tells more about what we are doing and what is Hyperloop to the people, while our public relations and business side does the same things, but also works with finances of our society, and also promotes the society in social media. Also, they developed a website to show people when they want to look for more information about us or Hyperloop. So what actually is our part when it comes to developing the Hyperloop technology as university students? One part of us is to find feasible ways of implementing the Hyperloop technology in where we live, starting with the UK, as Stella summarized in her findings from her team's research paper over the past 9 months. While the technical team tried various new technologies, such as linear induction motors, which you can see on the bottom right, which is the core of it, and tried to make it a more accessible, more feasible technology. Normally, if we would see such a linear induction motor, you would go above 2-3 grand, but we managed to keep it below £1,000 within our team with our designs. Also, we worked on carbon fiber aerodynamically optimized shells, which we handmade, which again reduced the cost of it. Also, we found out new ways of doing it by making it smoother and aerodynamically optimized. Another example that I can give is Halba arrays, which are permanent or electromagnetic magnets, which creates a specific pattern which either propels a pod or stops it. However, since they work with combining opposite poles, we needed to make them come together somehow, and we developed that technology further. It is a very, very rare technology, and we found a way of making it straighter, better, and cheaper. And also, our outreach team, as I mentioned before, went to different conferences, went to schools and gave online lectures, and still giving it as we are doing right now. Also teaches the public students about Hyperloop to inspire them in STEM and engineering. Now, I want to talk a bit about our achievements. We have been finalists in Virgin Hyperloop One Global Challenge with our proposed Hyperloop route in the UK from our research team. Also, we became finalists in the SpaceX competition with 4 of our pods, 4 of our prototypes, 3 of it being the actual pod that we developed and manufactured, and 1 being the design. Also, our predecessors started new Hyperloop-based businesses and did not stop in the university and went on developing the technology in their professional lives, such as Continuum Industries and Landsloop. Now, I think we can look at the close future, where we are going to have an European Hyperloop Week. As I mentioned before, we have been participants in the SpaceX competition, which was aimed to bring people from various universities and make a speed-based competition. And we have been a part of EHW. We are one of the 4 organizing teams. We wanted to change some bits of the SpaceX competition and make it based on a more innovative and make it a showdown of the innovative technologies that universities in the world have developed. It is going to be a more collaborative environment, and where the teams talk about the technologies and give seminars. Also, people will have the opportunity to talk with people from the industry who work in the fields. Also, we're going to shift the focus from achieving the highest speed to finding the most innovative technology among the participants. Now we can look at the future of Hype. What are we planning to do? What is next? So we're planning to finish our Greyfriars body, which is the pod prototype that we have been developing, and having tests of its technologies on our own test track, where we can test more freely and make predictions on the upcoming technology, instead of coming up with other ways of testing the technology, like coming up with rigs and finding out ways we can have more accurate tests in our own track. Also, we will work on combining the full-scale research that the research team does with the pod designs that the technical team does, and combine their findings into bigger research with increasing its feasibility. Also, we're going to, as always, continue coming up with new technologies and developing the Hyperloop field. As I've talked before, I think a good way to finish this is to see a video of one of the hull Baharets that we've designed and how we put that together. So the way that we did was we first went up to the manufacturers. We said, we asked them to manufacture it. We asked them to manufacture it and not ourselves, and they came up with a higher price, and then we decided to manufacture ourselves. We went to the past members. They wanted us to use wood, but then it didn't succeed because it was very disturbed. And then we came up with another way to do it, as you can see here, with the aluminium beams supporting the magnets. If you can see closely there, the compass there moves as we go over the magnets. So to finalize the whole presentation, please keep up to date with if you want to keep up to date with our recent developments, you can go to our social media, which we have the handles and the links on the screen now. And we would like to answer more of your questions and keep the discussion about Hyperloop and Hype. We're very excited to answer your questions. Thank you for listening to us.
Thank you, Arap, and indeed everyone else. We do have quite a lot of questions in, so if everyone wouldn't mind being a little bit snappy when answering, just to make sure we can get through as many as we can. I have a question here to Gregory. And the question is, why does a pod need to be aerodynamically shaped if it's traveling through a vacuum with no friction?
That is an excellent question. So if that question was asked towards AirOps section, our shell which we're designing is aerodynamically optimized because our test track is not going to be an actual vacuum chamber, since it's going to be an open air test track. But putting it more to the actual system, which would be hopefully implemented in the near future, it's not a perfect vacuum. Of course, everything is a near vacuum since it's impossible to achieve 100% vacuum. So air drag is minimized, but obviously not completely gone. So I guess you're right, there doesn't have to be an aerodynamically shaped shell for an actual Hyperloop pod, since the drag forces from that would be quite minimal compared to others.
There are still issues though with air pressure, and there are things to overcome with that, which is why many companies are also proposing to have an air compressor at the front of the pod to basically minimize how much air is accumulated at the front while the pod runs. So yeah, it's a lot less than you would have outside, but because you're moving very, very fast, even that little air that is there matters. So yeah, that's why basically they want it to be aerodynamically shaped.
Thanks, Stella. And if we can actually keep you on the line for a second, we have a question here, which is, have geological conditions been considered in areas where Hyperloop is proposed to go underground specifically?
In our case, not in depth. However, we are aware that this is something that needs to be considered. For us, it was more of these are some areas that we think would be best suited to having an underground system because of the kind of environment around them. But yeah, this is something that would have to be looked into more in depth before designing a finalized route of, okay, this is where Hyperloop is going. I hope that's okay.
It is okay. And no, there was, so you kind of touched on energy usage when you were talking earlier. So do those estimates include maintaining the tube in a vacuum the whole time? I imagine that's going to be quite energy intensive. Is that included in the calculation so far?
So from the sort of research that we've kind of gathered from the community, the energy kind of estimates are absolute of the whole system. It's not just the kind of propelling of the pod, it's the propelling of the pod and also maintaining the vacuum, because both need to be, as my colleagues have touched upon, need to both synchronously happen at the same time for it to obviously work as a Hyperloop system. So yes, the kind of sort of renewable energy will cover all of that if positioned along the grid effectively, would cover the energy usage of both.
So I'm going to ask this to anyone who wants to answer it. But the safety aspect was touched on a little bit earlier. And someone's asking, from a safety perspective, what would be the results of a rapid and sudden loss of vacuum around the moving pod? And what kind of measures can you actually take to make sure that doesn't happen?
It all depends on how rapid and how sudden, to be honest. But some safety measures that you can definitely have is that you can have a secondary air supply for however long people need to remain in the pod, and kind of similarly to what you have in airplanes. And then what Noor mentioned, the safe haven basically framework, where you would have safety exits at kind of frequent intervals along the tube, so the pod could move to where it needs to go to drop off the passengers and they can leave safely. And hopefully, based on kind of regulations and safety requirements, those wouldn't be too far from any given location within the tube. Those are some things. Obviously, there is probably more that can be done. It can be looked at. There can be more kind of preliminary work in terms of maintenance, how often these things are maintained to make sure that the possibility, like the probability of having that sort of event is minimal. And it would have to be something extraordinary that happens, and it's not just, oh, this pod is a bit old, look at that. So that sort of thing is also important. But yeah, this would come down to safety regulations in general that are not completed at this point in time, which is a shame, but working on it, and the industry in general.
Probably not the most exciting bit of paperwork for you all to do. So I'm kind of prioritizing the questions that are coming in from people watching, but I did have a quick question. So obviously this is going to go at quite some speed, and it's going to accelerate quite quickly and then decelerate quite quickly. How does that compare to the G-forces that you're getting, say, on a plane that's taking off? Is it not going to be quite unpleasant, sort of suddenly going from a standstill to however many hundreds of miles an hour very quickly? Or is that the kind of thing that you get on planes and stuff anyway?
Yeah, it would be unpleasant if you did it right away, which is why part of the kind of safety regulations would be how quickly you can accelerate and decelerate. So basically, you can't just go from 0 to 1,000 kilometers an hour as fast as your system allows. You have to give people time so that they are not experiencing anything that is uncomfortable. The idea is that you're accelerating in a few minutes rather than like a few seconds, or however fast your motor can accelerate, to give that kind of way for people to not experience the painful and harmful side effects of going very, very fast, very, very quickly. So yeah.
Fair enough. And I've got another question in here for Errol, which is that I suspect probably all of you can pitch in on this a little bit actually, but I mean this technology sounds incredibly complicated. How difficult was it to get started working on Hyperloop once you got stuck in? Can I add one bit on the end of that question, which is why did you all start working on it in the first place?
I think it depends how deep you go into the Hyperloop technologies. I think it takes a very long time to grasp all aspects of it, but if you would focus on specific parts of it, such as the propulsion or the brakes, I think it is hard to grasp all of it, but in a couple of years, I think you can have a very broad knowledge on it. But in my case, I think I started understanding what we're actually doing in 1.5 full years. But it really takes dedicated work and research. To answer the other question, how we started to work on Hyperloop and what was interesting about it. To be honest, I've always liked the idea of levitation and propelling with magnets. I always loved working with magnets, and then I've loved the idea of a maglev train to always search about it. Then I heard of Hyperloop and realized that Edinburgh had a Hyperloop team, and then I started joining last year.
Yeah, to add on that, on behalf of our founders, I think a lot of it can be credited to Elon Musk, I'll be honest, starting the competition, popularizing the idea. So I can definitely say our founders back in 2015, they were definitely got into the whole obsession per se of Hyperloop from that, along with many of the other student teams across the world, I'll be honest.
Yeah, and I would also add that what Errol said about it taking time to grasp the whole thing, it sounds a bit scary when you just put it like that, but I think it's important to understand that, especially in our team, we are all working in smaller parts of the full picture. So for instance, I was working on the full scale research team. I have no idea how manufacturing works, but I was quite good at answering research, like full scale research questions when I needed to for my team. And that comes with kind of looking into the specific aspects that you're interested in. There are obviously still a lot of things that I don't know, or Errol doesn't know, or any of us don't know, but that comes with any area of kind of interest. But yeah, it doesn't take a huge amount of time to get into it. It just perhaps takes more time to be very knowledgeable about your part, but just working on it, and it all comes with practice and work, I think, and it's interesting and fun, so we keep doing it.
I just wanted to kind of obviously echo the remarks of my my colleagues, but also, I mean, given that I'm coming from a non-engineering background, some of the stuff that interests me within Hyperloop technology, generally speaking, is all the kind of ancillary stuff, like the benefits to society, the impact it can have on the environment, and also, you know, kind of from the legal point of view, how would regulation seem? From a political point of view, I mean, how would a project such as this even be implemented? I mean, the government wouldn't have too much knowledge on this. They'd have to rely on advisors, industry experts. So it's quite interesting. I mean, from every point of view, from economics, from law, from politics, from every kind of discipline, there's a way to tackle or engage in the Hyperloop conversation. And that's kind of what we try and echo at Hype, that there's different parts to get involved with, and that's what we represent here. So yeah.
Very cool. I've got one really last quick question, which I guess I'm gonna put this to Stella. So Are professors or professionals involved in this project, or is this an entirely student-run thing?
So
I guess
for the
probably focusing on Hype specifically, if that makes sense.
For the most part, we are a student-led project. The reason I say for the most part is that we do have advisors from the university and also old members that are not students anymore. But their involvement is more in terms of, for instance, we'll give them a design review. We'll ask them to do a design review for us and they'll do that, or that sort of thing. In terms of admin within the team and who decides what we do and kind of who leads the whole project, it is a group of students, some of them present here at the moment. So it's for the most part a student-led project is what I would say, but we do have some help.
Very, very cool. Stella, and thank everyone else, thank you very much for that. That's it from me. I'm just going to very quickly hand over to Julia from Socio to close this out. But before I do, thank you very much, everyone. That's really interesting stuff. And please stick around for another 2 minutes.
Hello, everyone. I'm Julia from Socio, and I wanted to thank the amazing panelists for such an interesting conversation today. I hope you learn more about Hyperloop and how it might change the way we commute in the future. We had so many questions, so feel free to reach out to us if we didn't get time to answer them. Contacts are in the chat for both Socio and Height. And let's also thank Lauren and Sophie from the public engagement team at STFC, the Science and Technologies Facilities Council. They were helping us behind the scenes to make this event run smoothly. And of course, thanks to all of you audience for attending this event. At Socio, we want to connect experts to the public. We had events in the last months hearing the words of experts in physics and biology on various topics spanning from quarks to vaccines. If you missed them, you should definitely go watch them on our YouTube channel, where you can also rewatch this event if you wish. Don't miss out on future Socio events with plenty of ideas for giving you scientific content straight from the scientists' mouths. Subscribe to our channels on social media. Links are in the chat or in the description below. And that's all from me. A massive big thanks to all of you again from myself, Tom, and Shinran, and we hope to see you again very soon.